Today we're going to look at solving equations, and we're going to start with a really simple one. M plus 2 equals 7. So when you look at that, I want you to think about how would you solve it. And my guess is you would do what most people do, which is say, well, 7 minus 2 is 5. So M has to equal 5. And you're right. However, you haven't actually written it correctly in the algebraic sense. And to understand that, let's think back to the idea of a scale. Now, if we think about a scale or a balance, it has two sides, and if the two sides are perfectly balanced, and my line's not perfectly straight, but it's close enough. You get the idea. If it's perfectly balanced, then that means that the value on each side has to be equal. So think about that balance point as your equals point, or your equal sign rather, in an equation. So if we look at that, if we look at it that way, we could draw a picture of that m plus 2. We could think of it as some number that we don't know. So let's let our star represent some number we don't know, and a 2, because when we think about a scale, let's think about that's addition. We put two things together on a scale. We can only add or we can only gain or lose weight. So we're thinking about adding and subtracting there. So some number and 2 together equals 7. Well, what you're telling me is we need to take 2 away from the right-hand side. So we need to take 2 from 7 and make it 5. Well, the thing about that is if you think about a scale, if your scale is perfectly balanced, and then you take something away from the right-hand side, your scale is not going to be perfectly balanced anymore because it's going to have less value. So the other side it's going to not be balanced anymore. So thinking about that, it should make sense to you that if we have to take 2 away from the 7, we also have to take 2 away from the other side of the scale. So we have to also take that 2 away. And that really should make sense because now what this is showing you on your scale is that your star, or your missing number, equals 5. You can think about that being another scale. We've taken 2 from each side. Now it's still balanced. So let's look back at our original equation and think about what that should look like in our original equation. So yes, we need to subtract 2 on the right-hand side of that equation. And when I think about sides of an equation, the equal sign is what splits the two sides of the equation. So I subtracted 2 over here on the right-hand side of the equation. Well, I need to also subtract 2 on the left-hand side of the equation. So I'm going to subtract 2 on the left-hand side of the equation. And so you can see that I've done the same thing on both sides of that equation. And we talk about this idea in algebra of canceling. Things that are opposite of each other cancel each other out, or they undo each other. So what that means is this plus 2 right here and that minus 2, they do what's called canceling each other because they're opposites. If you add 2 to something and then you take 2 away from that, then you really haven't done anything because they cancel each other out. And we show that by putting a mark through them. Notice the only thing that's left on the left-hand side of the equation is the m, and on the right-hand side of the equation, 7 minus 2 equals 5. So we've worked out that equation. And we can go back and check and make sure we're right by taking our original equation and putting a 5 where the m was and asking ourselves, is it true that 5 plus 2 is 7? Well, 5 plus 2 is 7. So yes, it's true, and we now have the same thing on both sides of the equation. Both sides have a value of 7. So that means that we were right. Our m did equal 5. So we've done it correctly. All right, so let's get this, take a minute to write down kind of some steps for how we solve equations. I'm going to give you a minute to look at this and get all of your steps written down. You can pause while you're doing that. Yep, my E disappeared over there. All right, so looking at this, when we look at this, when we say ask yourself what kind of equation is this, what we mean by that is if it's an addition, we could start by looking to see what's being done to the variable. Is there something being added, subtracted, multiplied, or divided with the variable? That's what kind of equation it is. I'm asking what operation you see. And then we use the opposite operation, and our goal is to get the variable by itself. Remember, we've learned that whatever you do to one side of an equation, you have to do that same thing to the other side. That's how you keep the equation balanced and make sure your two sides stay equal. And then we check, making sure that we show where we canceled. So for our first equation here, we have m plus 12 equals 27. So our goal is to get m by itself and know what it equals. Well, to do that, we need to get rid of something that might help you is to box. What is it that we need to get rid of? Well, looking at my equation, I need to get rid of that plus 12, and then I'll have m by itself. The way to get rid of a plus 12 is to do the opposite of plus 12. The opposite of plus 12 is, that's right, minus 12. So we're going to subtract 12 on both sides of the equation. We're going to show what cancels. The two things that cancel are going to be the two things that are opposite of each other. The plus 12 and the minus 12 cancel each other, leaving just m by itself on the left-hand side of the equation, and then 27 minus 12. 7 minus 2 is 5. 2 minus 1 is 1. So we get 15 for m. Let's check it to make sure we're right. M plus 12, we want it to equal 27. So if m is 15, we need to do 15 plus 12 to see if that gives us 27. So 15 plus 12, if we work that out, you can come over here and do it if you need to. Yeah, it equals 27. So that shows us that yes, we were correct. M does in fact equal 15. All right, looking at another example. P minus 7 equals 9. So to do that equation, we're going to look and see what kind of equation is it. It's a subtraction equation because that's what we need to get rid of. There's a minus 7 here to get rid of. And how do we get rid of minus 7? Well, we do the opposite of it, which is plus 7. We're going to add 7 to both sides of this equation. So when I look at this, the minus 7 and the plus 7 cancel, leaving us with P on the left-hand side and 9 plus 7, which is 16, on the right-hand side. And when I go to check, I'm going to do P minus 7 equals 9. So we're going to put a 16 there and see if that works. 16 minus 7 is 9. So both sides of our equation are balanced. Again, think about that idea of a scale. The whole way down, the two sides have to stay equal. And if they do, then we've done our equation correctly. This next one, 20 equals 8n. Well, we need to remember that 8n means 8 times n. So we need to do the opposite of times 8, which is divide by 8. So when we divide by 8 on each side, this is what that looks like. We're going to use the division bar to show that. So when we do that, the times 8 and the divided by 8 cancel each other. Whoops. The times 8 and the divided by 8 cancel each other, leaving us with just n on the left-hand or right-hand side of the equation. And on the left-hand side, 20 divided by n. Well, look at that. That's really an improper fraction. 8 goes into 20 2 whole times with 4 left over. So we get 2 and 4/8, which can be simplified to 2.5. So our n is 2.5. Let's go back and check and make sure. I kind of jumped the gun there, but let's check and make sure that we've got that correct. So we can check that by saying 20 equals 8 times n. So we need to do 8 times 2.5, or 2.5 times 8, and we want to know, does that equal 20? So we've got to work out 2.5 times 8. And if I were doing that, honestly, I would probably change 2.5 to 2 5/10 and do it this way. And I do get 20. So we are correct. Let's look at another one. Let's just scoot further down and look at this one down here. So r over 6 equals 12. We need to understand that that over 6 means divided by 6. If you absolutely needed to, you could rewrite this equation this way, and that would be okay. So you should be able to see then that what we're needing to do is we're needing to do the opposite of divided by 6, which is multiply by 6 on each side of the equation. So we're going to multiply by 6 on each side. The divided by 6 and the times 6 cancel. Think about your equation like this. Then I'm going to do 12 times 6, and I'm going to get r equals 72. When I go back and check it out, I'm going to do r divided by 6. It's got to equal 12, so let's plug it in. 72 divided by 6. we want to know, does it equal 12? So we're going to do 72 divided by 6. And it does, in fact, equal 12. So we have worked that out correctly. X, or R rather, does equal 72. Okay, we're going to do a couple more of these. I'm going to go through this pretty quickly, but I'm going to point some things out to you as we go. This first one here, 17 plus R equals 24. I want you to notice some people get a little about that because the 17 comes first and they want to do a minus R, minus R. Well, you could do that, but that really doesn't help you solve it. It doesn't make much sense. If you needed to, think about commutative property. We could change the order of that addition. You could rewrite it as R plus 17 equals 24. If that makes more sense to you, then do that. Or the other thing you could look at is to see, well, I have a 17 being added that I need to get rid of. So I'm going to subtract 17 on both sides of the equation. The other thing I want to point out to you is when you look at this, a lot of people like to put the minus 17 on both sides right next to that line they draw in the middle. It really makes more sense to put it over here underneath of where you're what it's the opposite of, because then when you cancel, it's real easy to see there where you cancel, leaving us with R equals 24 minus 17, which is 7. And when I go back and check, 17 plus 7, does it equal 24? Yeah, it sure does. So I have done that correctly. All right, another example. T divided by 4 equals 28. I need to get rid of the divided by 4. The opposite of divided by 4 is times 4. So let's do that on each side. Times 4 and divided by 4 cancel, leaving me with T equals 28 times 4 is, let's try that again. 28 times 4 is 112. And if I go back and I work that out, I want to make sure that T divided by 4 has to equal 28. So 112 divided by 4, I want to make sure, does it equal 28? And when I work it out, it's definitely going to work. So I do, in fact, get 28 there. So that tells us that T does equal 112. 3 equals H minus 11. Now, sometimes people get a little bit not sure about this because you have your variable on the right-hand side. Well, guess what? There's no reason you can't switch the order of the expressions and rewrite it to look like that. That is perfectly acceptable. If that makes you happier, do that. But you don't have to, because you're always going to look at where the variable is, and your goal is to get the variable by itself. So look at what's on the same side as the variable that you need to get rid of. It's a minus 11. So I'm going to add 11, do the opposite, add 11 to both sides. The plus 11 and minus 11 cancel, leaving us with 14 equals H. So when I work that out, and I check it, and it works. So we're right. 14 is equal to H. Last one we're going to do together, one more. 6n equals 42. Remember, 6n means 6 times n. So we need to do the opposite of that times 6. That gives us, makes us want to do divided by 6. So the divided by 6 and times 6 cancel, leaving us with n equals 7. And when I go back and check it, it is absolutely going to work out. 6 times 7 is 42. So that shows me I have done it correctly. That gives you the basic idea for solving equations, and you can solve all equations using this method, and it doesn't matter whether they have decimals or fractions or negative numbers in them. You still use that same process of using the opposite operation or inverse operation to solve the equation, no matter what kind of number you have there. Some computations are harder than others, but the process itself doesn't change.